Today we are starting arithmetic progressions, and in arithmetic progression we have terms with a regular difference. Suppose the first term we have a, then the second term would be a plus d, and the third term a plus 2d, a plus 3d, and a plus 4d. Similarly, up to nth term a plus n minus 1d. So we will work out on this arithmetic progression, and the nth term, when we add up to nth term, we will get n by 2 a plus this one is nth term. This L is basically the nth term, so in place of this L we can place this nth term here, so we will get this result. So this is the sum of all the progression up to nth value would be resulted like this. So if nth term has to obtain, we can find the difference of nth term to the n minus 1. So n minus 1th term sum to the nth term, the difference of these two will provide us nth term. So we are starting exercise 11.3. So the first term in an arithmetic progression is a, and the common difference is d. The first term in an arithmetic progression is a, and the common difference is c. Write down expression in terms of a and d for the 5th and the 14th term. So for the 5th term and 15th term, we will write down. For the 5th term, it will be a plus 4d, and for the 14th term, it would be a plus 13d. So this is so simple because n minus 1. So 14 minus 1. So here we have 4 minus 1. So for the second, find the sum of this arithmetic series. So we have to up to 15 term, up to 20 term, and 30 term, and 40 term. So this is all easy. For third one, we have to find the number of terms and sum of all these arithmetic series up till this. So we'll first we'll see the results, the solutions of these first three. For first one is a5 is 5 minus 1, a plus 4d, and for the 14th, a plus 13d, as discussed earlier. So this is 2a up to 15 term. So 15th term, so n is 15th, so s15 is equal to this, n is 15 by 2. So here in place of n we write down 15, difference is 9 minus 2, 7, 16 minus 9, 7. So this difference is 7. So we will write down and we will get this. This is simple. For this 20 terms, we have write down this. For this 1.5 difference, this is easy. 1.5 difference, we get this. For this value, we will have this minus 2f. So we have this one, number of terms. So for equation 3, the number of terms, we have to find this sum of each arithmetic series. So this is the last term, 159. This is a, and the difference is 4. So we'll write down d is the difference. We have to find the value of n. So we have find the value n is equal to 35. So for n 35, we'll find the difference. If sum of this all the terms. So we have obtained this 3a. Similarly for 3b, and for the fourth problem number 4, where the first term of an arithmetic progression is 2, and sum of the first 12 term is 618. First 12 term is 618. The first term is a is given as 2, and the first 12 term is 618. Find the common difference. We have to find the value d. third part has not discussed, so this is easy. So fourth one, A is given as a 2 and S12 is given as 618, and D we have to find the value of D. So this is simple. For S12 we have write down this 12 in place of N. It's simple, we have obtained D there. So for fifth problem number 5, in an arithmetic progression the first term is -13, the 20th term is 82 and the last term is 1, but find the common difference and the number of terms and find the sum of the terms in this progression. So we have given A is equal to 13, the first term, and the 20th term is 82, and A and the last term is 112. So from these two we have D is equal to 5. We have find out the D. So in place of this we can write down A and D here. A is given, so we can find the value of A, which is 26. So we have to find the sum of all the series up to 26. So we can write down like this. So this is the first one, -13 is there, this N is here, and the difference is here. So we can find S26 as this. For problem number 6, first two term in arithmetic progression is 57 and 46. The first two term, this is A and this is A plus D. The last term is this one. Find the sum of all the term in this progression. Find the sum of all the term in this progression. So we have given these two values and we have to find differences. So A is this, A plus D is 46. So A plus D minus A is equal to D. So the difference of these two is difference D, and An is given as 207. From this 207 we can obtain value of N, which is 25, and placing the value 25 we can obtain S equal to this. This is easy. And similarly for 7th, problem number 7. The first two terms in an arithmetic progression are this. The last term of the progression is the only number in the progression that is greater than 200. The last term in the progression is the only number in the progression that is greater than 200. Find the sum of all the term in the progression. So we have to find the value N. So we have A is equal to -2, A plus D is 5. This is given, and An is greater than 2, while N minus 1 is 200. Because it's less than 200, the nth term is the only term that is greater than 200 is a given information. So we can use this information to obtain this An value. So this A plus D minus A is equal to difference is 7, because this is -2 and this is 5. Difference between this is 7. So D is 7. So in placing the value of D7 we can obtain An as this in this expression. So the result is N minus 1 is this. So N minus 1 is this. N is greater than this. So N is greater than means the term is the 30th term. That one is the 30th term. So for An, N minus 1, N minus 2 is less than 200. So we can see that N minus 2 is less than 28.86. So 30th, less than 30th and greater than 29th. So the term is 30th. So between this and this, the only positive integer exists is 30. So we have obtained this. This is very important question, may be asked in final exam, not in a O-level CI exam, but IGCSE exam as well. So problem number 8 and problem number 9. Problem 10. Now discuss problem number 11. Rafu buys a boat for $15,500. He pays for his boat by making monthly payments that are in arithmetic progressions. So he pays first month, and the second month he increases the amount, and the third always increasing. So he pays for his boat by making monthly payment that are in arithmetic progression. The first payment that he makes is 140, and the debt is fully repaid after 31 payments. Find the fifth payment. So we have to find the fifth term. So this is the sum value. So this 11th problem, go for this 11th one. Here we have A is equal to $140, N is 31, S31 is 15,500. We have to find this A5. AN is equal to A plus N minus 1D. N is 31. For 31th term is equal to 30D. A plus 30D. We can write down is N is 31. So this is 31. SN31 is equal to 2AN minus 1D. And for S31 we have 15,500. This is 31 by 2. This is 2, and first one is 140. We have write down all these things here, and the result we have obtained D is equal to 24. So this is D is equal to 24. The difference is 24. So for fifth term we will pay $236 instead of 140. First, initially he paid $140. In the second term he increases it by $24, and this is 3 times 24, 4 times 24 plus 140. So this is $236. Similar for question number 12 can be solved, and 13th, 14th, 15th. Let's discuss 15. Problem number 15. The sum of nth term Sn of a particular arithmetic progression is given by Sn is equal to n upon 12, 4n plus 5. Find an expression for the nth term. Find an expression for the nth term. So we have to find an. So this is given. First n terms have Sn, arithmetic progression given by this Sn is in this form. Find an expression for the nth term. So this is the problem, and you have to solve it. So this is given as this. So S1 is this. In place of 1 we can write this. S1 is 19 by 2, 12. So this is 3 by 4. So A is 3 by 4. The first term, for when n is equal to 1, we have this S A is equal to 3 by 4. By 3 by 4, this second term we have this 13 by 6. So this is the difference as obtained as this is equal to 4 by 6. This is 2 by 3. So for nth term we can write down like this. So this is very important and could be asked at least in IGCSE or even in CAIE. This is very important. And question number 16 and 17 all available here. 18th. Now let's talk about the challenge question 19. The first term of an arithmetic progression is cos square x and the second term is 1. Write down an expression in terms of cos x for the seventh term of this progression. Seventh term for a n, and where n is 7. So, and second one is show that the sum of the first 20 term of this progression is 20 plus 170 sine square x. So we will solve this part A and B. This is a challenging question. A1 is equal to cos square x. So a plus d, the second term is given as 1. So from this we have the difference is 1 minus cos square x. So instead of this, a7 is equal to a plus 7 minus 1. The nth term is 7. So this is something like this. So this is 6 and this is 1 6 means 5 cos square x, and this is 6 is here and this is here. So a7 is given as this. The seventh term is given as 6 minus 5 cos square x, which is given in the form of cos x. So the sum of 20th term is given as this. We have to show that the sum of first 20 terms is 20 plus 170 sine square x. So S20 is given as n is 20 by 2. Here we have the first term cos square multiplied by 2 because it is 2a. This is 2a plus this is 2a and minus 1, and this is d. This is d. So we have placed it in a simple arithmetic sum for the first 20 terms. So in this way we have this value 20 minus 1 is 19, 1 minus cos square equal to 1 minus cos square. So we have solved it, and this is minus 17 and this is 19. So here we have 10 and multiply this is 19. Yes. Instead of this we can write it as 1 minus sine square x in place of cos square x. So this becomes 1917 and this is 1790. This becomes 2. This one is 17 sine square x. So multiply with this 2, 20, and 10 multiplied by 17 is 170 sine square. This is 170 sine square x. We have to show this. So we have proved that this sum of first 20 term is 20 plus 170 sine square x. So this was question number 19. That was a challenging one. It was a very difficult one, and